Pulleys. Pulley problems have long been popular in mechanics courses as a good way of exploring student understanding of forces and the constant acceleration formulae. Consider a basic pulley problem as shown below. So here we have some sort of horizontal fixed surface like a ceiling. We've got a pulley here and we've got masses M1 and M2 at A and B. The weight here would be M1G and here M2G. Since the pulley is usually taken to be light and smooth, we would have tension here and tension here, and that would be the same tension because of this modeling assumption and the fact that the string is usually taken as light and inextensible. Suppose that M2 is greater than M1, so this object is heavier. What's going to happen when we let go? It's going to accelerate so that this object accelerates downwards and it pulls this one upwards. Now we know F equals ma. So if we look at A and we just consider this object, the resultant force is going to be T take away M1G. So that's our F. And then we'll have M1A. So we have T take away M1G is equal to M1A. So if we now consider B, the resultant force here is M2G take away T, and that's going to be equal to M2A. Now consider the forces at the pulley. So the tension is going to act both ways in a string, so the tension pulls down on the pulley. And if we've got 2T pulling down, we need 2T pulling up.